Let's discuss triangle similarity. The first important thing needed to know is that there are three similarity theorems that could prove two triangles are similar. One of those theorems is side, side, side. Another is side, angle, side. And the third one is angle, angle. Okay? One of these three theorems must be used to prove two triangles are similar. There's no other theorems to prove two triangles are similar. Please be sure you're copying down everything I am copying down on your paper, just as I am copying it. Okay, so let's go ahead and first look at number one. The instructions tell us, state if the triangles in each pair are similar, and if so, state how you know they are similar. Now again, these three theorems are the only three theorems that prove that these triangles can be similar. So if none of these three work, they are not similar. So let's go ahead and take a look at number one. Number one, we have an angle. In our first triangle, an angle in our second. Remember, angles are on the inside of a triangle, while sides are on the outside. Okay? So we got an angle in first triangle, angle in the second, and they are equal. Okay? And then we have a side, another side, and another triangle, a side, and another side. So we got a pair of angles and two pair of sides. Could it possibly be side, side, side? No, you're correct. It cannot be, because side, 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 I need all three pair of sides. We have an angle here. Could it possibly be angle, angle? No, you're correct. For angle, angle, I need two pair of angles. Right now, I just have one pair of equal angles. So perhaps it may be side, angle, side, but we have to check and make sure our sides are actually proportional. So when we see if our sides are proportional, we're going to set up our sides in a fraction. If the two fractions are equal, then they are actually proportional. So I'm going to take 72, and in my fraction, it's going to correspond with 132. Okay? My other fraction, oh, what do you know? It's 72 again. And my other fraction is 132. Well, we don't even have to simplify these. Are these fractions the same? Yes, they are the same. So that marks off for one side. That marks off for the other side. They are proportional. And now angle. Do we have one pair of angles that are equal? Yes, we do. So you would say, yes, these are similar because of side, angle, side. Simple. Good. Okay, let's look at number two. Let me change my color pen here. Okay. So number two, same direction. Say if the triangles in each pair are similar, and if so, state how you know. Okay, we have some intertwining triangles here. And in my class, I like to think of triangles intertwined like this as a bow tie. So we usually think of Mr. Ellison or Mr. Ellis's bow tie when we see triangles like this. And whenever we see triangles that are in a bow tie, we can identify that there is an X in the middle of those triangles. And when we see that there's an X in the middle of those triangles, we know we have a pair of angles called vertical angles. What do you know about vertical angles? That is correct. They are equal to each other. This angle here and this angle here are equal to one another because they are vertical angles. Okay, so let me erase the X off for a second. Okay, we know that these two angles are equal because they're vertical angles. What else do we know? What does this box mean? That box means 90 degrees. Good. Oh, what does this box mean? It means 90 degrees also. So that means this is 90, this is 90. Okay. So these two angles are equal, these two angles are equal. Let's refer back to our three theorems and see which one of those theorems could possibly prove that these are actually similar. We got side, side, side again, side, angle, side, and angle, angle. Okay, side, side, side. I need three pair of sides. Do I know anything about any of the sides? No. Okay, so nope. Side, angle, side. Again, I know nothing about sides, so there's no way that can work. Even though I have angle, I have no sides. Only one that could possibly work is angle, angle. Now with angle, angle, I need two pair of equal angles. What do you know? I got a pair in the middle, and I have a pair that are equal to 90. You don't have to know what the degree is in the middle. You just need to know these are vertical angles and that they're equal. Now, hint, vertical angles will never be marked equal. A picture, a question is never going to tell you these two angles in the middle are equal. Uh-oh. It's never going to tell you that. You have to know these are vertical angles and that they are actually equal. So because we got a pair of equal angles here, we got a pair of 90-degree angles that are equal, then yes, they're similar because of angle, angle. Circle my first answer there. Okay, moving right along. Let's look at if we have similar shapes, as the directions say, they are actually similar, to find the scale factor. Okay, scale factor. Remember, scale factor is written a number, colon, a number. That's as simple as scale factor. You just have to figure out what those two numbers are. So make sure you pay close attention to the instructions that says go from smaller figure to larger figure. That means start from the smaller shape. On both of these questions, start from the smaller shape to find the scale factor. So if I am trying to find a number, colon, a number to find my scale factor, I'm going to start from a smaller shape. I want to find two sides that are corresponding. And when I say corresponding, I mean they sit in the same place but on different shapes. So 24 sits at the bottom right. What do you know? 40 sits at the bottom right. So I can use those numbers. 24, colon, 40. That's scale factor. Just got to always make sure to simplify. So in your calculator, 24 divided by 40. And that will give you 0.6. Now remember, scale factor needs to be a number, colon, a number. So in your calculator, hit the math button, enter, and it's going to turn that decimal into a fraction. And that fraction is 3 over 5. But we want a colon in the middle, not an actual fraction sign. So our scale factor for this problem is 3 colon 5. Let me highlight that for us. 3 colon 5. I'm sorry, that wasn't such a good highlight. Okay, on to our next question. Okay, again, scale factor from smaller shape to larger shape. We have 3 different sides here, okay? And we have all 3 pair of sides correspond. You can pick any pair of sides that correspond. It does not matter which sides you pick that are corresponding. As long as they correspond, you can get the same answer. So let's try the top. I have answers for the top, and their scale factor would be from a smaller shape to the larger, 15 colon 18. Even if you did it for this side, 15 colon 18. You'll still get the same answer, 15 colon 18. As long as the sides correspond, you'll get the same answer. Don't forget, we can't leave it like this. We have to do what? Simplify. Good job. So 15 divided by 18 in your calculator. That's going to give you 0.8333, a lot of threes. That's called a repeating decimal, by the way. Okay, I don't want a decimal, though. I want a number, colon, a number. So what's our next step? Good job. Hit math, enter, and you get 5 over 6. I don't want a fraction sign. I want a colon in the middle. So 5 colon 6. And that is our scale factor. Quite simple. Again, scale factor. Read the directions. If it says larger to smaller, then start with the larger one. However, these instructions say small to large. So take a number, find its corresponding side on the other shape, and just simplify that fraction. Okay? So that is our scale factor. Pause the video as needed if needed. Okay? And finally, our last topic here we're going to cover is finding the missing side in 2 triangles. All right, we got 2 triangles. You guys see the 2 triangles? Sometimes when they're intertwined like this, it's a little hard to see the 2 triangles. So here's one triangle, that very small triangle. And the other triangle is the very big triangle. So you got the really small one and then the very big one. Okay, so we're going to erase that, as long as we can see the two triangles. All right, the question is finding the missing side length. We are trying to find this missing side right there. So how do we do that? Well, let's think about it. We are going to use our sides that we have and set up a proportion. Do you remember proportions? It's a fraction equal to a fraction. So we're going to take the information we have in one triangle and figure out what information we have in the others and try to use those to set up a proportion. Okay, so this is somewhat of a two-step problem. We're trying to find this missing portion down here. We still want to set up a proportion, but what proportion do we set up? Now, in order to find this part here, there's no corresponding side on this side for us to set up a direct proportion to do that. So, with this one, we actually will have to find this missing side here and then do a little math to figure out what's down there. So we have, in the big triangle, the left side is 15. In the small triangle, the left side is 6. Okay? Be consistent with your fractions. If you start with the big triangle for the first fraction, make sure on the next fraction you start with the big triangle. So what number will go on the top? 20. That's correct. The big triangle is 20. The small triangle at the top, we do not know, so we're going to put an X there. And how do we solve a proportion? Cross multiply. 6 times 20. And that gives us 120. Keep the equal sign in the middle. And 15 times X is 15X. I'm going to switch my color here. In order to solve for X, they're multiplying, so do the opposite of multiplying and divide both sides by 15. You're going to have X by itself, and that missing side up here is 8. Okay, so that little part is 8. That's what our proportion helped us to find, 8. But let's think about it. If the whole thing is 20 over here, this little part is 8, what do I need to do to figure out what's missing? You got it. 20 minus 8. So that little missing part is 12. So this one was actually a two-step process. It still involved you setting up a proportion. But after that proportion, you just had to do a little subtracting to get to the final answer. Okay, the second one is not so bad. Okay, we're finding the missing side length. Same concept. Set up a proportion. Set up sides that correspond with one another and cross multiply. So let's start with 27. 27 is the longer slanted side. Okay, so let's figure out which one is the longer slanted side here. That would be 45 equals. Remember, be consistent. I started with the left triangle here. Make sure we start with the left triangle for our second fraction. So I have 15. 15 is that shorter side. So our shorter side here is that question mark or X. And now we can cross multiply. So we got little big numbers here. 27 times X. 27X. Keep the equal sign in the middle. 15 times 45. A big number. It's okay, we can do big numbers. 675. And the last step, good. Divide both sides by 27. And X is equal to, you got it, 25. So the important thing with proportions is to be consistent. Whatever information you put first in your first fraction, make sure you put that same information first in the second fraction. Okay, so that is a review on focus topic 3, similarity triangles. Make sure you got all the notes. If you need to rewind some, go ahead and do so. And now it's time for you to practice on your own.